for sure.
Yeah, yeah.
Hey, Sampath, good afternoon.
Yeah, good afternoon. Yeah, let me know how can as per your experience, how what's the impact of
So
your semiconductor, yeah, on
so I
automotives.
think we probably missed two waves, yeah. So I mean the Y2K was one era. I mean the starting where we missed the wave of semiconductor. Probably I think the software was not up to the mark, yeah.
Yeah,
So that was one part, yeah, and then probably the um, that's when the automotive industry started working on electronic control units and going towards software defined, you can say AutoSAR or
okay.
Jaspar and these kind of middleware in the components. Yeah, similar to Linux. Yeah, you have a middleware layer, then you have an ECU and a services layer, and then on the top. So and 20 years now. Yeah, I mean the other one was the Lehman Brothers crash, of course, that everyone knows in 2008, which was another turning point where we could have actually invested in the uh, the semiconductor industry as well. But of course, you didn't have the right what do you call the amount of cash flow to actually do such an investment at that point. So that was another turning point. So the third one is of course this pandemic, which was in a way, the chip shortage which happened during the pandemic for almost all the automotive cars, right? Car manufacturers, if you see the issues, or if you take any hardware in loop systems, or if you take any um, you know uh, systems as such, right? I mean the whole components, if you want to put it in the cloud, right? So
Yeah,
essentially everything was, I think this pandemic is this is the opportunity where we have to look forward to actually kickstart the the semi in a good way. Probably I mean India missed the chance a couple of times. That's where TSMC and everybody started almost
yeah,
having a monopoly of the whole industry. Yeah.
yeah.
So of course we had design houses. We didn't in 2000 after the Y2K, the Hyderabad cluster, the
Mm.
I think Karnataka, a few clusters. So these were probably design houses. I mean, which was basically similar to ARM kind of models, right? Where you actually sell your designs and in fact, when after the assembly, I mean, after from the fab house, you get the chipsets. You actually put it in a development board, then an
Yeah,
emulator, then actually do the put it in a hardware in loop system, and that's where things started moving, right? So and that process starts. So we missed all that because we were actually importing chips from wherever the foundries were. So either it was mostly TSMC and maybe a few Samsung or SK Hynix in Korea. I mean, that was 2 3. So in that way, I think automotive industry, I think the way the chipsets have grown, right? I mean, if you look at the automotive industry also, right? So earlier stage was ECUs. You had only probably for a radio or a infotainment system, you had an ECU.
yeah,
Then of course, electronics started kicking in, right? So right from body controllers to heating systems, HVACs, um, all through the braking systems, chassis systems, suspensions. So everything software started kicking in. So you can say an electromechanical system, yeah. So
yeah,
mechatronics. So electronics started going into the, and along with that, software also started moving through. So that's when the software push into the electronic components happened. So and automotive also became like a what do you call an IoT kind of thing, right? So essentially a
mm.
mixture of sensors, actuators.
Like a
Um,
connected cars, like, yeah,
yeah, yeah. The whole system is an IoT, right? I mean,
yeah.
it's an system of IoTs. Yeah, you can say
Hmm.
a lot of sensors, say camera sensors. I mean, any kind of sensor, right? So anything from temperature sensor all the way till radars, cameras,
Yes,
lidars, ultrasonics,
yeah, yeah,
whether you do a parking system or whatever it is. So that was a phase where the ADAS and the autonomous vehicles started kicking in, right? So everything was, you had a sensing technology, so that needed some chipset or a system on chip or a specific, that's where
yeah.
it caught in, yeah. Then this AI wave and this disruption started happening. So that was the last phase, yeah. Then that's where
Mm.
you saw mostly a software defined structure,
Yes,
yeah.
yes, definitely.
Everything software defined. So whatever the AI wanted to do, the software was defining things. So
Okay.
in a way, you had to push your um, chips to earlier days it was all 25 nanometer. Whatever I would say, 33 nanometers, and those were the standards. Yeah. So now it became to sub 2 nanometers and chiplets
Yeah.
kind of things. Yeah, almost 3D ICs and everything coming on.
Yes.
And the you had a balance of the GPUs also pushing in the power. Yeah. So CPUs or GPUs. Of course, there were also the GPA, FPGAs, which were actually going into the fast hardware in loop kind of systems. Yeah, which were
Mm,
mostly car as a car on a lab or whatever you want to call that. Yeah,
mm,
to actually push that speed of how the actuators are happening in the real world system.
okay.
So so
Regarding this,
eventually,
the hardware
yeah.
security also, right? Yeah.
Yeah, of course. So eventually, what happened was you had too many hardwares in your system, and everything was connected. So
Mm,
somewhere you actually pass through a gateway through some setup.
yes.
You actually take control of things inside the system. So it became almost like what do you call a smartphone or a computer as such. Yeah, it's
Yeah.
like a smartphone on wheels or whatever you want to call it. So essentially, if you actually take control of through an infotainment system or whatever, yeah, door systems or whatever, you actually take control of braking, and so that resulted in cybersecurity change, which almost became like conventional cybersecurity on a kind of server kind of technology. Yeah, you can say it was a server on wheels or
Okay.
controlling a system of
Yeah.
things, and you had to put something in place which was making sure that the components were decentralized,
Mhm.
and you had to like the firewalls and whatever the endpoint securities, you had to do the same kind of systems into the car as well.
Okay.
So whether it's a car, bus, or whatever, yeah, so any vehicle. So that's where cybersecurity started kicking in. So eventually, what happened was, yeah, you can call that, although you cannot use the same software which is running on your laptops or your
Yes.
smartphones, or because these are systems which have very less interaction between. We only have a human machine kind of HMI kind of interface. Yeah,
Yes.
cars are more systems which actually have environmental and other kinds of things which actually happen. Yeah,
Yeah.
so there is a way. Yeah, you want to call spoofing of sensors, or there were so many kinds of attacks which happened, which led to given rise of cybersecurity threats at a large scale. Yeah, you are seeing, of course, in India it was not much of a problem because you never saw such kind of attackers doing
Mm,
full blown attack onto a car and
mhm.
taking the car for a ride just like that. So
Okay.
yeah, you had the DEFCONs and others happening in the US, but
Okay.
rather in India, you don't see unless it's a too expensive car, and even then you get caught in the ecosystem, right? So
Yes.
if it is a too expensive car, you're not, it's only going to be one or two on the road. So definitely, yeah, I think we were in a phase where, yeah, in India was well better placed. Of course, our even our electronics into the cars were also not as much as in the Western countries or in the Japan or
Okay.
Middle East kind of.
Okay.
That was the difference. Yeah. So there the attacks happened because the conversion already happened to the software defined world.
Yeah.
So you had the attackers who had the possibilities of taking control of anything, right? With
Yeah.
with a cable connected or whatever you
Yes.
need to do. Yeah, electromagnetic interference going into some technology and pushing in some keys, whether it's in a hardware security storage or whatever they call. Yeah, push it across and break it through. Yeah, so that was the way attackers started doing things in the Western world.
Mm,
So, which is okay. In the sense, yeah, I think people started to realize, of course, we needed security for cars also. Yeah. So,
yeah.
IoT security, car security. That's when, yeah, I think this pandemic also boosted that because we were also seeing bring your own devices kind of thing in the factories, right? So,
Mm,
wherein even your infrastructure, even your endpoint security was kind of breached in some of the systems and production plants and things like that. So, So which is I think the cybersecurity in the industry also woke up. Yeah, so everything woke up in a
Yes.
whole new different world. Yeah, and data intensive is also another thing. Yeah, because the data started pushing in through much of the pipelines into larger and larger chipsets or system on chips, right? So the mechanism of putting an extra data on top, and you don't even realize that it has actually gone through some of the interfaces,
Okay.
um, made a difference. Yeah, secure channels, or you want to call secure firewalls, or even the endpoints for some of the sensors, right? You don't even realize that it has actually passed through the firewall, and it has actually gone through. Just change a couple of uh, machine codes, and you change the corresponding CRCs with whatever the headers and footers, you make it into the system. So the difference was, yeah, cybersecurity, they needed something which was much more safe, and we are seeing a phase where it's even not secure. When you say you have the quantum computer sitting at one end and also trying to push something, yeah, which
Yes.
is unbelievably. I mean, you can crack anything within which you're taking years together to in. So you're seeing the next wave of the sophistication. Yeah. So wherein yeah, you have something like almost like a Turing machine, you can call it, yeah, with the quantum and the
Okay.
AI coming together. Yeah. So
Mhm.
the yeah. So
So we have strong demand for semiconductors. So there is a large talent gap also, right? Also, and
yeah, I mean, of course, see, I mean, to be frank, yeah, even I was a hardware engineer, so electronics engineer from the the Y2K learning period, when yeah the system started changing very different. Yeah, but the opportunities for at that time into the semiconductor designers or RAM or whatever you call, right, or the system designers like the Cadence or Synopsys was very few in India. Yeah, probably for the elite IITs or
yeah,
that was case. Yeah, so at that time, of course, many people decided to switch, yeah, to the software field, and that's how the talent was converted into mostly system software or firmware engineers, or a kind of um, uh, AI kind of course, the people who laid the foundation for ADAS and those kind of technologies, right? So that's where we actually moved there. So which yeah, I mean, which was I think at this point, if you had investments to make, and if you had some fabs running, then it would have been a different scenario altogether. Yeah, because we would have people who would have seen a wafer house and clean room technology kind of things. Yeah, although we had the contractors ready, right? I mean, you saw KLate and Core and Applied Materials, and some of the instrumentation guys already coming up. Yeah, so only the IMEX or the ASMLs or somebody needed to actually
mhm.
push in the high-end wafer into at that point. Yeah. So that was where we were lacking. Of course, we were doing some components which were bigger in size on clean room, but if you see to the what do you call the millimeter? I mean, whatever. Yeah. So nanometer kind of sub nanometer or 5 nanometer. I mean, you needed such a sophistication that where the investments were almost uh, rather a high point at that time. Yeah, we missed the gap. We could have invested. Yeah, and then now TSMC says something around $20 billion might be needed for a fab, which is of a greenfield kind of thing. Yeah, so. And India, what I saw recently was it around $10 billion was put in the budget, and 2 billion already taken or something like that. Yeah. So I think we are still behind. Yeah. Although CDAC and others probably did few experimentation with
Okay.
few of the players. Yeah. But to the kind of experimentation that the West or Japanese or Koreans trying, we are still we are lagging behind, right? So we are still in the waiting in the queues of TSMC or Samsung or whatever. Yeah. So we're waiting the queues for that to get our chipsets ready. Yeah. So I think still
Okay.
there is a chance. Only thing there's that, yeah, bring in more investments and bring in more people to invest in the sophistication. Yeah.
So government has
That's a good
announced
point.
some schemes like on like PLI schemes, specs and all. So I couldn't see much automotive people into that.
Yeah, I mean, automotive already had that ecosystem which was established, right? So,
But even the
uh,
startups did not come up most like that.
yeah, I mean, the point was automotive already had a chain ecosystem. Yeah,
Mm,
because in India, what did we have other than the Tatas and the Mahindras? Most of the other companies are from outside. Yeah,
mm,
so they already have that chip ecosystem along with them. So if you take the US,
okay.
there was already Intel or whatever it is along with their
Mm,
fabs, AMD or yeah,
mm,
Nvidia's now, and so they had the system. Samsung had their Korean systems for Japan, of course, had their own players along with Taiwan, which were actually doing that. So Germany, of course, ASML and a lot of IMEC and others doing the job for German countries also with the vendors, right?
yeah,
Semiconductor vendors. So if you take Japan, it was Renesas along with East. If you take Renesas, SK Hynix, Samsung, few guys. Here, Freescale along with NXP. Yeah, that's the US side
okay.
of things.
You said.
Infineon in Europe. So so essentially, they had the supply chain ecosystem already in place. Yeah. So now, yeah, there is a point where they also realize that yeah, they are also in the queue. Yeah, because of this pandemic, everything was shifted into the Internet of Things or whatever we
Mm,
see the devices around. Everything has electronics in it. Yeah, you
mm,
wear a smartwatch to smart goggles to whatever. Yeah, Elon Musk is saying chip inside a brain. So yeah, so essentially, you're seeing a phase where everything is becoming um, software defined and electronically controlled.
mm,
So in this phase, everybody realized, okay, we can't be still depending on TSMC or one player as such. So we need to set up fab centers across the world. So what happened was the investments were already taken across into Germany, France, UK, US,
mm,
or Mexico, or whatever it is, right? So that kind of investments were already taken. So here, the players who are dependent on the kind of semiconductor here are now less, right? Because Tata also have taken
yes.
over JLR. So JLR essentially has access to Europe or the UK kind of mechanism for the chipsets. Mahindra also has Korean, of course, Italian companies coming in. Yeah, so they can actually depend on their own supply ecosystems.
Okay.
So naturally, the you don't need, of course, for the self-sufficient kind of thing. Yeah, I mean,
Yeah. In
we need to get into that.
yeah.
We need to get into that phase here sooner or later. Not
Okay.
only in automotive, but I'm also thinking of Internet of Things kind of thing. Where everything becomes controlled by electronics and chipsets. Yeah,
Mm. Regarding the self-driving cars, also some unmanned vehicles, right?
unmanned vehicle.
So yeah, the government is restricting some policies and guidelines in India, right? I could able to see some news.
Yeah, I mean, of course, you can't avoid that. I mean, we are a country. We have to
Yeah,
accept that our population cannot be put to rest with
yeah,
only
right.
everything autonomous, and we are just sitting and controlling it from somewhere, or it is
Mm,
autonomously running. We can't do that. So in that way, we are not an economy which is in shortage of people or in shortage of resources for anything. Right? So in that way, we are not a people short kind of country, right? Or a technology also, right? So we have to adopt in a phase where unmanned can come not necessarily to the kind of sophistication which is in the Western world or in the Eastern world, but to a certain extent, yeah, it can't be level 3 or level 5 or whatever, yeah, beyond kind of things, yeah, kind of Tesla or whoever is attempting that. So, what can be driver assistance systems, which you saw in the early 2000s to the second decade, where everything, yeah, you can see in the cars, which is, yeah, the Mahindra, Tatas, Hyundai's. You can see the rear parking control, imagery systems, radars coming in few more cities and stuff like that. So I think you are seeing that, but you can't do it fully autonomous like in the US or anything. So that's where our legislations, of course, it's not up, it's also about the safety of people here. We rather try to save more lives and give the importance of not breaking any rules and stuff like that. So uh, yeah, we are a densely populated country. In that way, we don't have much experimentation setups to carry out unmanned
Yeah, yes.
unless you are in the middle of Rajasthan or
Yeah, yeah, like that.
that's
Yeah.
only in control circuits. Of course, it will get to a level of autonomy at a stage when the Western world has already got into that stage, yeah.
Mhm.
And it's proven for 5 years.
Okay.
We will also get into that stage. By that time, our sophistication may be for the fabs, as you said, right?
Mhm.
People would see investments into the fabs and sub nanometers, sub 2 nanometers kind of technology with AI chips coming into
Mhm.
the unmanned uh, the
Yes.
vehicles or drones or whatever you want to call it. Yeah,
Mm.
it will eventually come through. Yeah, so probably yeah. Still, we are waiting for the others to finish up the trials and we'll take it up next year.
Okay.
So it is going to happen eventually.
Mm.
Maybe we'll see a legislation push much later when the US and Europe have and Japan have proven the grounds. Yeah, and that's where our things start to coming to a balance. Yeah, we also need. I mean, we cannot say that it's completely on the uh, car or the vehicle, right? So you also need the um, infrastructure or even the kind of sophistication we need to do for that. Yeah. So even the automotive world, we had some chipsets which were actually not having security clearance in India. So we had exposed resistance on those kind of chipsets. So unless you have certain kind of licenses to actually get it across, um, so there were no policies which were you can actually supposed to be used in India. So
Mm.
the cars or anything which is actually coming to India is a cut down. You don't have the sophistication which is there in the West. Yeah,
Mhm.
that's also
Okay.
another thing. Yeah, and you don't need that sophistication. Ultimately, there is a need for if you need it, you utilize it. Yeah. In our kind of conditions, you're not going to drive your vehicle at 200 miles per hour, or
Yes.
that's not going to be possible unless you are in yeah, the kind of highways which are actually
Highways,
connecting.
correct. Yeah.
So that's where, yeah. So level 4, level 5, yeah, it will reach a stage where at least in the highways you can see that happening.
Mm.
But by that time, if more people are going to buy cars and the number of transportation
Yes.
units are going to increase, then it's a different ball game at that point of time. Yeah, we are
Mm.
always catching up with what do you call uh, people moving into urbanization as well as going into the next stage of buying cars and stuff like that. So, and that's where we realize, okay, we have missed a phase. Okay, and
Mm.
the same thing is happening now. I mean, it's you're missing. If you miss this phase again, you will be after 5 years. You will realize, okay, we missed the autonomy. Okay, now autonomous systems have proven. Okay, now let's go into it. So probably at that stage, yeah, at that stage, yeah. I mean, you might have so many fabs across the world. Probably India
Yes.
will see the light at the end of the tunnel. That's what I can say.
They are expected to put
At
two
least with
apps like that.
yeah, I mean 2 and 3 year. I mean for our
Mm.
population as well as for the technology, I don't think it's sufficient. Yeah, so
Yes.
we need something like large in number. So
Yeah.
and then because of the influx of electronics as well as the software defined systems, so you need more at least a handful or at least 10 or
Okay.
yeah, I mean of course it's expensive. I know that definitely. I mean when TSMC says $20 billion, you have to value
Yes.
it's been there for years and it knows how the investment happens in a greenfield. So definitely, yeah, when we are actually allotted something like a $200 billion for a semiconductor fab, people might okay. then we are seeing a different ball game altogether. Yeah. So
Mm.
uh,
So what is the
we'll have to
emerging
wait.
demand here in the automotive now just after the autonomous cells?
I think the same trend is continuing. Yeah, the
Okay.
autonomous level three. You are seeing systems. Yeah, you are seeing Mahindra's getting into the system. So Tata's getting into the system. Also, the electric vehicles also getting catching up. Yeah, the hybrids and electric vehicles catching up. So now you are seeing almost like smartphone on wheels, right? So
Okay.
you don't have the conventional power strain or the engine in the whole body, right? So you are utilizing it for a battery pack, and the ecosystem is totally changing. But still, you need chipsets to control the battery management system with inverters, converters, whatever, yeah,
Mhm.
motors, motor control, and all these things which are still needed. So the point is, yeah, I mean, for a connected vehicle, you need it. Autonomous vehicle, you need it. For personalized or shared mobility, you need it. And of course, for a electric vehicle, also you need it. So so the or it's a green hydrogen kind of technology. Of course, you need it. Yeah. So there is a need. Only thing is that we have only players like Tata and Mahindra. Unless the local players like Ola and other things start catching up in the OEM phase, yeah.
Mm.
Uh, then yeah, I mean, of course, even the two-wheeler market, right? Two-wheelers also have started utilizing, like TVS,
Yeah.
Hero, Bajaj,
Yes. Yes.
also catching up. Royal Enfield, yeah.
Yeah.
So everything is catching up. So of course, there is a need. So definitely, even two-wheelers are getting into the ARA space, or what you call as rider assistance system. So
Mhm.
they're also the battery electrics with ARAS, advanced rider assistance. It's called. It's not instead of driver, they've given rider assistance system. So
Mm.
a different nomenclature, but almost a similar kind of technology. So
Okay.
and that is also becoming connected. You have the Android clusters coming in. You can see the Ola vehicles and others with
Yeah,
Android
I
or
see.
so you need chipsets for sure. You need, yeah. So
Okay.
yeah, definitely there is a demand. Demand is there for everything. Only thing is we have to see the investments. Yeah, you said the PLI scheme today. I saw it's only $10 billion. Yeah, how
Mm.
many people can actually go
Yeah.
at that rate for?
Yes.
Which is at an initial point of time, at least for a fab like something of a sophistication, you need more investment. So because it's not about the whole fab, right? It's about the whole technology plus the supply chain plus the materials you are actually um, getting out of the fab.
Yeah.
You're proving the technology. So it's a process in it's a loop already. So you need that money to actually uh, unless you're Tata or Birla, I mean, even they are not making kind of
Yeah.
industry investments at that scale now. So
Yes.
uh, that's the yeah. Probably, yeah. I think when the Olas, TVS, everything starts waking up at some point, they will actually, uh,
Mm.
yeah. I think everybody will start waking up. Not the one or two fabs, but the whole ecosystem start.
Okay.
And there is also the process of learning the technology, right? So, of course, you cannot go from directly into sub 2 nanometer technology to start with.
Yeah.
Uh,
Correct.
that's another thing. We'll have to start with some passive or active circuits along with those kind of technologies. So I think it's a balance of things. Yeah, and you can also see PCB design going into ChatGPT. That's what the latest news. So everything is coming to place. Only thing is that you need more investments at the right time. So um,
Okay.
probably, yeah, I think,
So I will stop my recordings like this. Yeah. Only.
yeah.
Thank you.